Scriptable objects are standalone serialized assets. Unlike mono behaviors, you don't need to, and can't, attach them to a game object. Scriptable objects aren't here to replace mono behaviors, they're here to be used together with mono behaviors, and complement each other. You can have a mono behavior that holds a reference to a scriptable object instance, and then changes its appearance and stats based on its data. Dividing the work, where our mono behavior is a shell that takes action based on the provided data in the scriptable object. We can use this strategy to slim out a busy editor. We might have a lot of variables like speed, jump height, and character sprite on the character component. We can replace those with a single scriptable object reference that is tailor-made to store those values. This strategy can allow us to have multiple preset variations, which we can plug into that mono behavior and see the change instantly. An added and important benefit to this approach is preventing duplicated data on prefabs that would otherwise share the same values. Whenever you instantiate a new prefab, it would get its own copy of the values described in the mono behavior. If those values are the same across all instances, we can replace those value variables with a reference to a scriptable object, where the data is stored once and used by many copies of the prefab. Scriptable objects are perfect as data containers or modules that can hot swap into place for dynamic experience. However, that's not the limit of their power. Using scriptable objects, we can introduce some new patterns into our codebase, like the event pattern, or extend and improve an existing one, like the singleton pattern. Today, we'll check out the basics of scriptable objects and use them as editable data containers. We'll go over the other patterns in the future, so make sure to subscribe and hit the bell icon to stay tuned. So let's get started. Creating a scriptable object is straightforward. Instead of extending mono behavior, extend scriptable object. And that's it, you're done. This class is now a scriptable object. However, an empty scriptable object is not very useful for our purposes, though even that has its own use case. Here, you can declare any variable as you would in a regular C# class, and it would be editable in each instance of this scriptable object. Before we dive in, let's take a quick look over the lifecycle methods of a scriptable object. I made two classes you can play around with to get a better understanding of when each event is triggered. As you create, modify, and delete instances of this lifecycle SO, you will get messages in the console telling you which event got fired and a quick description of the conditions required for it to fire. Now onto the example. We're going to remake the customization feature from our new game Break Orbit, where you can change the spaceship and speed of the character. When we look at our character, we can see 4 variables we can customize that would alter the look and feel of the spaceship in-game. We have our speed float, sprites for both the spaceship and character, and a gradient for the trail color. We can modify it and rerun the game. Now suppose we wanted to have multiple variations of the player on the screen simultaneously. In that case, we'd have to duplicate a prefab and modify each prefab. Then save each prefab as a variant, flood in our prefab folder with a bunch of variations, or creating a complex script to save and parse presets. If your head hurts just from the thought, don't worry. Scriptable objects are here to make it easier. We can make a player config scriptable object, which would hold all the customization options we need. Then we create as many instances of it as we want presets for our players. So let's get started. We'll make a scriptable object just like before, and I'll name it player config SO. We need to add our customization variables here and remove them from our mono behavior, player controller, replacing it with a reference to our newly created scriptable object class. Next is updating the various references in player controller to use our new configuration scriptable object. And the refactoring is complete. Let's save and allow this to compile and go back to Unity. As you can see, our script is here, but we have no way of creating a new instance of it. So let's do that next. There are a couple ways of creating an instance of a scriptable object. You can use scriptableobject.createinstance. This method will create an in-memory instance of a scriptable object type provided. Quite frankly, I rarely use this. What you'll often use is the create asset menu attribute. Add it above your class for the default settings, or feel free to configure it further if you'd like. This attribute would add an option to create an instance of our scriptable object to the context menu. Now go back to Unity, right-click, and create a new instance. Doing so would create a new instance of our player config SO class as a serialized asset file. You can tweak it in the editor just like you would any other mono behavior. Now let's make a few instances and modify each of them. You can now drag one of those presets into our player class, run the game, and there you go. We decoupled our data from the controller class, giving us more room for easy customization in the future without any hard-coded modifications. Now, when working with scriptable objects, it's important to remember that, unlike mono behaviors, any changes you make to an instance of a scriptable object at runtime would remain after you stop the game. For example, let's run the game and edit the old class by changing its speed value and vehicle. Next, let's change the same values on our scriptable object. If we stop the game now, we can see that the monoBehavior component returned to its original value, while the scriptable object retained its runtime value. This might be a desirable outcome, but sometimes you want the runtime value to return back to its initial value after you stop the editor. If you have some variables in a scriptable object that you'd like to return to their initial value, you can split them into two, one for the initial value and one for the runtime value. To prevent accidental overrides of the initial value by other classes, we'll make the initial value private and serialized. We don't have to serialize the runtime value, but that's up to you. Other classes would access this value, so let's make it public. We need to implement iSerialization callback receiver interface, and inside onAfterDeserialize, we override the runtime value with the initial value. Doing so would guarantee a fresh copy of the initial value every time we deserialize this asset. Lastly, we'll just update player controller to use the runtime value we declared and go test it in Unity. We'll set an initial speed and run the game. You can now mess around with the runtime speed. And when you restart the game one more time, the runtime value would reset back to the initial value we provided. Hopefully you have a better understanding of scriptable objects now, or at least learned a few new tricks. It's important to note that the way you use scriptable objects is entirely up to you. You can make them as granular or complex as you'd like, from empty or single value scriptable objects to preset behemoth with dozens of configuration knobs and buttons. If you enjoyed this video and want to see more content like this, please subscribe, leave a comment below, and hit the like button. It helps a lot.